Right, so welcome to the third lecture. So today we're going to talk about routing. So up until this point, you will have in the labs, once you get into the labs in a couple of weeks, you will have built your Prometheus virtual machine, which is where you will perform all of the tasks on the lab sheets. And then in the lab sheet before this one, you will have built your virtual network. That virtual network will consist of three virtual machines that will live inside your Prometheus virtual machine. So the network structure that you will have will be something that looks like this. Now, after you've built that network, you will have one problem. The virtual machines in here will have no internet access. Okay, does anybody know why that could be? Any idea? Yes? Half of the answer, yes, I'll give you that. But what does that mean in terms of the connectivity to the outside world?
So NAT takes a private IP address and translates it. NAT stands for network address.
Yeah.
Only translates into a public IP address.
Okay, so this translation process is what nothing does in order to give internet access, or rather access to a world past the network's default gateway, to all of the computers inside that network. So now if we're not nothing, if we're doing host only, then this translation doesn't exist. This means that by default, as all computers do, you cannot send and receive packets across different subnets, across different networks, unless there's somebody there to tell those packets where to go. That somebody in our case, and in most networks case, will be routing. Okay, so we need to have a router in place that will be able to take one packet and say, oh yes, this one is coming from the outside world and it's supposed to go onto network 32, onto the IP address, whatever. In order for that packet to go there, I need to send it across that interface to the other computer, and then that other computer needs to send it to the other one, and so on. So if you are sitting on vPrometheus 2, for example, and you want to access the internet, vPrometheus 1 will need to know that if it gets any information from it that's going to the outside world, it needs to forward any information from VMnet 2 onto VMnet 1. Once that's out of there and it goes onto VMnet 1 on Prometheus, Prometheus also needs to know that the information coming from there needs to go to the outside world, and Prometheus will know that the outside world is out through the ENS33 network card, which is on subnet 28. So what we'll need to do for this particular lab sheet is we'll need to set up routing on your Prometheus virtual machine first, and then we'll also need to set it up on vPrometheus 1 as well. So let's look at the process in detail. In order to do all this, we need to set up a software router somewhere. So we need to turn our hosts, our computers, into routers. So they not only need to be able to forward packets from one network card to the other, so of course they need to have more than 2 network cards or more in order to do this. They also need to know which networks the information needs to go, so which networks are accessible beyond what the computer itself already knows. So at the moment, if you're sitting on Prometheus, Prometheus will know network 28, which is the physical network card that connects it to the outside world, and it will also know about network 30 and 31. Why? Because those network cards are directly attached, exist on Prometheus itself. So Prometheus has 3 network cards on it, 28 that connects to the outside world, 30 that connects to vPrometheus 0, and 31 that connects to vPrometheus 1. Now, if something is to go to network 32, for example, Prometheus needs to know the way to go there. All right, so all of the computers need to build what we call a routing table. So they need to have the directions essentially so that information can travel from one host onto another through multiple interfaces on those hosts and end up in the correct location. Now, in order to do this, the first thing that we will need to do is we'll need to make sure that the network structure that you have on your computer is correct. So you need to boot up all of your virtual machines. So you need to have all of your network running, and you need to make sure that you can ping your neighbors. So you should be able to ping without any issues from 0 to the host, from the host to 1, and from 1 to 2. Okay, this should happen without you having to do anything at all. Now, The second thing that you will need to do after powering on these machines, you will need to go onto the network card of Prometheus that is called ENS33, that doesn't exist here. Okay, it's your network card that connects you to subnet 28. It's the network card that connects you onto the outside world. You'll need to make a change in there, and this is very specific to how we use the lab. You'll need to change the subnet mask in there from 255.255.255.0, which is the default class C subnet mask, onto 255.255.254.0. We're doing this because we have sort of connected subnets 28 and 29 together. So any of the computers, any of the 254 computers that are on subnet 28 will also be able to communicate after you make this change with any of the computers that are on subnet 29. We've done this so that we can double the amount of computers that are available in our network. Okay, you particularly probably will not need this, but this is the way that the lab is set up. We call this supernetting. Okay, it's the opposite to subnetting that I showed you in the previous week. Essentially, instead of taking away bits from the right-hand side of a default subnet mask, we're giving more host bits to the left-hand side. I can actually show you this on the board, and I will, so that you understand it. All right, so a default class C subnet mask is 255.255.255.0. Okay, let me do this so that I can record all of it. Okay, so how does this translate into decimal, into binary? We have 1, 2, 3, 4, 5, 6, 7, 8 ones. 1, 2, 3, 4, 5, 6, 7, 8 ones. 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. Okay, so each of these numbers, each of these parts is in 8 bits in binary. Now, how do we convert this from binary to decimal? We add stuff. So first bit is 128, second bit is 64, third bit is 32, 16, 8, 4, 2, 1. All right. If you add all these guys up together, you get 255. Now what we have done in the lab is we've taken away this here and we've turned it into a 0, which means that we now disregard this. So our new subnet mask ends up being 254. Okay. Now this means, as far as you are concerned and as far as how you will use the lab, the computers in the lab, it doesn't really make any difference to you. What it does make a difference to is the routers. So the lab's router, Columbus, will see this 254 in there and will realize that it is able to route information onto subnet 29 as well if it needs to. Okay, you will not need those extra IP addresses. This is just a setup that we have in the lab. However, if you don't have it like this, if you don't make this change, your routing will inadvertently not work, no matter how correct all of the other settings are. Because Columbus, our lab's router, is expecting a .28 subnet, which is on the different number of bits, which is working on 254. Okay, so once you do this, you're clear to move on to the rest of the tasks on the lab. Let's make my head smaller than this, take my space. So how do we do this? We have a program that needs to be installed, and that program is called Quagga. Whoever designed the routing on Linux was a big animal lover, nerd, whatever, had a zoo, worked in a zoo, who knows. So initially named the software Zebra. So the initial daemon was called Zebra, and then they made lots of updates and fixes and stuff on it, and they decided to call it Quagga. A quagga is a different type of a zebra. If you go to London Zoo, I have a picture next to the sign that says quagga. It's me being very nerdy. Anyway, so you need quagga on your computer. To get it to work, you need to first do absolutely everything in this lab sheet on Prometheus only. Yeah? You need to turn your Prometheus host into a router so that then you can actually go on to vPrometheus 1 and run yum install Quagga there, and it will install Quagga on virtual machine 1. So this labsit needs to happen in stages, needs to happen in 2 stages. You need to follow all of the tasks of the labsit for Prometheus, and once you do that, you will have internet access on 0 and 1, and at that point, you can install your routing software on virtual machine 1 as well, and then you can give internet access to virtual machine 2 as well. All right. Now, yum install Quagga will simply fetch the software from the internet, and then this depends on 2 configuration files. So, the files that we will need are 2 files, zebra.conf and ospfd.conf. They will live in the folder etc Quagga, which you won't have unless you've installed Quagga onto your system, and they look something like this. Zebra.conf has its main function in life of telling the computer which interfaces we will be doing our routing on. Okay, at the moment, for your Prometheus virtual machine, you will have ENS33 that gives you access to the outside world through network 28, and then you will also have the 2 virtual network cards that are VMnet 0 and VMnet 1 that give you access to networks 30 and 31 respectively. Okay, anything that has a hashtag in front of it is a comment. So VMnet 2 in this case doesn't work. You can leave it commented out, or you can delete it completely just so that you make the file look pretty. It's totally up to you. Okay, so zebra.conf must exist and must know all of the network cards that you will be doing your routing on. ospfd.conf, on the other hand, will need to tell us a couple of things. First of all, it has an OSPF router ID. So it will need to tell us which computer is doing the routing. So the ID of the router for this network. In my case, it's 148.1.7.28.50 because 50 is my IP address in the lab, so that will be whatever IP address your ENS33 network card actually has on your computer. Once you've done that, you then need to declare the networks that are directly connected onto your computer. You are working on Prometheus. Prometheus for you owns network 28.0, or rather is connected onto network 28.0, because all of your computers are connected to 28.0, so this line will have to be the same for everybody. And then you need to declare your networks 30 and 31. In my case, my network address is 30.252 or 31.252, and that's because I am working on the very last line of this file. So my network address is 252. In a similar manner, for all of your computers, your network addresses will need to be the ones that are here. Very common mistake, people put the first usable IP address there. That will not work. This file is used so that you advertise the networks that are connected onto your computer onto your neighboring routers. Networks, not IP addresses. Okay, so make sure that you use your network address from here. The /30 is important because it's a 30-bit long subnet mask that this network is using, and the /23 here is because we've made the change here and we've gone from 24 bits onto 23 bits for our subnet 28. Okay. Again, network 32 is commented out. I've put that there for your convenience because you will need it in order to configure routing for virtual machine 1. All right. So that's that. So this is what your configuration files should look like. Zebra.conf will be the same for everybody. All of your network cards are called the same. So your Prometheus Zebra.conf needs 0 changes in the lab. Okay. ospfd.conf will need to know your network addresses and your router IP address. Once you've configured all those, we are then ready to prepare the system so that we run everything that we need to run. There's 2 things that you need to do. One is to enable packet forwarding. By default, it's disabled on Linux as a security measure. So you can enable it with this command. You need to do the command only once, and it will take hold forever until you change it. Okay. The other thing that you will need to do in its simplest form is let routing through the firewall. Now, because this is beyond the scope of what I'm doing on this lab sheet, the easy way out of this is to clear all of your firewall rules. So IP tables minus capital F will flush your IP tables. If you would like to look into it and figure out how you actually can let routing through the firewall and implement that command instead, then I'll give you a couple extra marks for your troubles. Okay, but both are valid. You can do whatever you like, it's fine with me. So, we've downloaded the software, configured the two files, put them in the correct location. We've disabled the firewall or allowed access through the firewall, and we enabled packet forwarding. We now need to be able to basically run Zebra in OSPF and see what happens. So I would like you to do it first in debug mode. So I would like you to run them on a terminal so that you can see that door should be open. I don't know. Hello. So I would like you to open 4 terminals for this, or 4 tabs in a terminal. In the first terminal, you will need to run zebra-f, etc. quagga zebra.conf. So that will run in the terminal. It will make the cursor disappear because it will run live on the terminal. You shouldn't be able to run anything else, and you shouldn't get any messages back onto this. If you run this and you do get a prompt and you can still type commands into this, then something is wrong. This usually happens later when you run it as a service. So the thing is already running as a service and it's not running in a terminal because of this. So you need to do service zebra stop if that happens. But theoretically, the first time you run this in debug mode, it should just run. Second terminal, ospfd-f, etc. quagga ospfd.conf. Now this window should show lots of stuff. In fact, it should show all of the root exchanges that happen between your router and the other available routers in the network. So your virtual machine, your Prometheus virtual machine, will need to send information to our Columbus and get information back from Columbus as well so that it builds its routing table. That routing table, you can watch it live if you open a third terminal and type the command watch root -n. What that will do is it will show you your local routing table for the first 20 seconds. And then once routing starts working and you get all of the other information from Columbus, you should get some more routes appearing there. Once everybody in the lab starts getting their routing working, you should be able to see other people's routes being advertised there as well. So you should see their 30 or 31 networks with their corresponding network addresses show up on that routing table. Usually when we do that lab, I will connect onto Columbus, open a terminal there, and put up the routing table of Columbus with this command on the class's projector. So the first test to see if your routing is actually working is to see if your network actually appears on Columbus's routing table. Once that's done, you then can test this. You can try pinging from vprometheus0 and vprometheus1 to the outside world, pinggoogle.com. Don't forget, in order to do this, you must have configured your DNS settings on your network cards. You should have done this when you do the virtual network. If you haven't, then make sure you do it now. So at this point, you have routing working on Prometheus. You have internet access on virtual machines 0 and 1. So now you need to repeat the process exactly as you just did now on vprometheus1 as well. All right. The principle is the same. You need to install the software. You need to download the files. You need to edit them. And you will need to run everything in debug mode in vprometheus1 as well. The difference with this will be that your zebra.conf on here will not have an ENS33 anymore. It will only have a VMnet1 and a VMnet2. Alright, and it will not have a VMnet0 either. And your ospfd.conf will need to have a router ID of whatever IP address you have, let's say on your network card VMnet1. And the networks it will advertise to the rest of the world will only be networks 31 and 32. So it will not know about networks 28 or 30 by itself. It will get this information once you run it, and it gets all the information from your Prometheus virtual machine. So once you configure this, you will be able to run routing on vPrometheus 1 as well, and that should give internet access to your third virtual machine, vPrometheus 2. So that will mean that your entire network has full internet access everywhere. Now that you've set everything and you've tested everything, it's time to stop the services running in debug mode. So you need to go back to your terminals and press Ctrl+C to stop the processes in the Zebra window and the OSPF window. Don't just close the windows, because the processes might hang in the system and still be there. So if that happens, you will not be able to do service Zebra start. Okay. Once you do that, then you can do systemctl restart zebra.service and restart ospfd.service. I always do restart just in case. And then you can also do check config zebra on and ospfd on. Those last two statements will set the services to run automatically at startup every time you boot your computers, every time you boot your virtual machines. Check again that everything works and make sure that you can ping google.com from vPrometheus 2 and 1 and 0, and you are good to go. If you get all this done and you have plenty of time, you can either move on to the next and last lab sheet, which is DNS, or you can try to implement some nutting here. So you can clone vPrometheus 2, again, same process, you just copy and paste all of the files and rename the folder, assign VMnet 3 to it, add VMnet 3 to vPrometheus 0, and nut it. So essentially, this new virtual machine will need to connect behind here. So you need to add the second network card on this by running fix vmnet dev, and you have another virtual machine in here, and you need to do nothing behind this one. This is so that I will show you, so that you understand, so that you learn how nothing actually works, like the logistics of it, outside of what VMware actually does with VMware itself, with the software itself. Okay, it will not be the same process as routing. There is a command, which is an IP tables command, that will actually allow you to do this. Okay, you'll just need to sort out the IP addresses and everything else and figure out how it works. And of course, we will help you do it in the lab. And there is an example file. So there is a file that gives you an example of the command that you need to use, which is located on Moodle, and of course you can refer to it as well. All right, so you can get some extra help from that one. So by the end of this lab sheet, we're not too fast about the bonus round, because we don't really mind it too much. So if you don't manage to do it, it's not the end of the world. All right, you can still get the 7 out of 10 marks for this lab sheet. All right, but by the end of this lab sheet, you should definitely have internet access to all of the virtual machines that you have in your network. Okay. Any questions about this? Yes?
Each week in a lab is each lab sheet?
No. So there are only 4 lab sheets, but you'll be in the lab for 6 or 7 weeks. So there is more time. Plus, of course, the lab is open access, so you can come in the lab and work whenever you like, whenever your computer is free. Yes?
Can we access or practice in the lab soon? Or we have to...
So we can't, because it's not ready yet. Okay, I haven't prepared what I need to prepare in order for the systems to be ready for this module. Okay, it will be ready after we finish, so we have 1 more week of lecture after this, and then we have, I think there's a week of break, and then we start. Okay. Anything else? Would you like me to explain anything with regards to the IP addresses, the subnetting, supernetting thing again at all? I will explain it in the lab as well when we get there.
Is there a way, like I seen someone, like a friend mentioned to me something about remote access. You can do it here.
Not anymore. So we used to do this during COVID, but then we stopped because there's no COVID anymore.
If you want to work in the lab later, we have to come.
Yes, you need to physically come in. The lab is open until 8 or 9 o'clock in the evenings, and the timetable of the lab is posted on the door of the lab, so you can see exactly when there is a class running in there or not. But even if there is a class running in there, if you drop by and there is nobody sitting on your computer, you can ask the lecturer permission, make your phone silent, and sit and work on your computer, and it's fine. Okay?
There's another question.
Yes.
There's a session I read on, like, by the door.
Yes.
Wednesday, 1, 2, 3.
Yes.
Is that weekly?
Not every week, no.
How do I know if there is or not?
I don't even know. You need to ask Dr. Reynard for this.
Would they also help us with the Linux and the logic? Like, is it a good source of understanding?
Other member of staff that are in there might or might not help you, depending on whether they know or whether they have time. Okay. So if I'm in the lab doing something and somebody asks, yes, of course, I always help. But this isn't the case for everybody. Okay? Anything else? All right, thank you very much.